Hello everyone, and welcome to the first run of the cold moonlight test. First thing I want to do is do it. Everybody has been asking me, point this thing at the sky. So as you can see, the light coming directly off the moon, about 38, negative 38. Negative 33, negative 34. So even though it's in the negative, the moonlight is warmer than the air. Now before we go in and talk about the experiment, let's take a look at the ground. I am in a cul-de-sac. You can see the ground anywhere between 15, 16 C. I'm doing a circle. And here's the experiment. It's hard to tell, but on the left-hand side I've got a table, chair, laptop pulling data from temperature sensors, some other equipment, and then on the right is my 8-inch Schmidt-Cassegrain telescope. And you can see I have 3 dowel rods coming off the back of it with a sheet of plywood attached. Now, the eyepiece has been completely removed, so there's no obstruction, no extra lensing coming off the back. This is just the concentration from the primary and secondary mirrors of the telescope. And you can't see it in this, but I'll do a side-by-side. There's a perfect image of the moon being cast upon this cardboard. And that image, just to make sure, I've got to shine a little bit of a light so we can see something. There we go. This is one of the temperature sensors. Yeah, let's find the end of it. That's a piece of tape right there. That is the end. You can actually kind of see the moonlight there. So we are at 13.1, 13. That is concentrated moonlight. It's a crescent moon, or half moon. 13.2. And then as we come out, right here would be in shade from the moonlight behind the telescope. And then as we come over farther, in direct moonlight again. So 12 degrees at the edge, direct moonlight. 13, low 13s for the shade. And then in the concentrated moonlight right there, 13.2. So as of right now, I can say that there is no evidence to support moonlight having a cooling effect on this cardboard. About 20 minutes ago, I put the cover on the telescope. So for 20 minutes, there has been no concentrated moonlight being cast upon the backboard. So let's check it out. Okay, that is the end of the sensor. That is about where the moon was casting, and we are now at 11.1. This is a preliminary proof of concept. No definitive conclusions are being made. The measurement of the temperature by the FLIR camera was not methodically conducted for placement on the cardboard, but will be done so during the actual experimental runs. I did not use the IR thermometer because I honestly forgot that it was in my toolbox. The temperature sensors provided by Where's Wally were used, and the concentrated light did register an average of 0.3 degrees Celsius decrease. This decrease also registered on the open air thermometer. However, the 4 sensors have historically had variations between the 4 even as they're bundled together. I'm going to do calibration tests of the 4 sensors as they're bundled together to see the variations between the two as they are physically tied. Data will be gathered across multiple days to see the variations within the sensors. From this run, I've learned a few lessons that I'm going to apply for the future tests. Number 1, take the no moonlight test data first. My plan is to align the telescope shortly after moonrise and then immediately set the sensors up and then cover the mouth of the scope. I'll then allow the scope to track the moon for several hours without exposing the sensors to concentrated moonlight. Then I'll remove the cover and take several more hours with the concentrated moonlight for more data. Number 2, adjust the scope, not the sensors. I didn't have a perfect alignment for my scope, so the moon was slowly drifting across the cardboard. To correct for this, I physically moved the sensor back under the concentrated moonlight. It never did leave the moon while it was attached, but it was getting close to the edge. This also resulted in the sensor being out of the moonlight briefly while I was making the adjustments. Next time, I'll continuously adjust the scope to keep the moon on the sensor rather than the sensor under the moonlight. Number 3, charge the FLIR during the run. I used the FLIR multiple times during the run, however I didn't make videos each time, I just wanted to see what the sensors were reading. But I didn't pay attention to what the internal battery was on it. This resulted in the last video, this one you're looking at now, to be cut short because the battery died. Note to self, charge while it's not in use. And number 4, take FLIR readings from the ground below the scope about every hour. Next week, weather and work permitting, I plan to run several experiments on the days before, of, and after the full moon. Each night will only be with one different backing material. I have cardboard, wood, and rubber as backstop material to see the differences in the temperature effects based upon the moon. If anybody sees anything else that they feel would make this test more valid and remove variables that I'm not thinking of, feel free to leave a comment below. All the input I've gotten so far has been very valuable, and I appreciate everyone's input. As of yet, I have not heard from any flat earthers as to how I can make this better to suit their needs, but again, I will gladly listen. So, thank you for joining me. Stay tuned for more.